Have you ever wondered how liquids or fluids exist or store in the subsurface? When I was little, I imagined that there were some ponds or pools of liquids underground. Well, now I know that they are actually stored in a tiny pore space in between rock grains. But does that really matter? Let's do a simple experiment to help us visualize it. For this experiment, I need some cooking oil and some water, and I've added a little bit of blue food coloring for a better visualization. 2 mason jars, one is empty, and for the other one, I fill it with lots of marbles. I'll start by adding the water into this jar. And then I'm going to add the cooking oil and fill it close to the top. Then I'm going to put the lid on. Once I'm done, I'm going to shake it a little bit. And that's very interesting. As you can see, when I shake it, the jar becomes cloudy. This cloudy mixture is an example of an emulsion, which forms when mixing 2 immiscible fluids, and one fluid is dispersed in the other as bubbles. The bubbles scatter the light, causing a cloudy appearance. Without any stabilizer, the emulsion is not stable, meaning that if we wait long enough, it will separate into 2 separate phases. It's like when making a vinaigrette dressing. As you whisk the vinegar and the oil together, it forms an emulsion, and often we add other ingredients such as mustard to help stabilize it. After waiting for about 5 minutes, the 2 phases have mostly separated. You have the yellow oil phase sitting at the top and then the blue water phase at the bottom. Next, I'm going to repeat this for my jar with lots of marbles. I'm going to pour the oil into it, so kind of roughly halfway through, as you can see. And then I'm going to add my water. So that's kind of interesting because water is heavier, so the water would want to float to the bottom, while the oil would have a tendency to try to float to the top, very much like the other experiment that we have. So here's the fun part. Put the lid back on and I get to shake it. So let's take a look at what has happened. So as you can see, the blue water bubbles want to flow towards the bottom of the jar, and that's because gravity is pulling the heavier phase to the bottom, and those little tiny oil bubbles are trying to move to the top of the jar. So I thought, okay, how about if I wait another 5 minutes, maybe the 2 phases will have completely separated. So I waited, and even after 30 minutes, when I went back and take a look at the jar, I see that the blue water kind of got stuck in some of these spaces between the marbles in the jar. And there's still some oil bubbles stuck in the supposedly the water phase. So what happened? In fact, after many hours, nothing really changed. Some water is stuck at the crevices while some oil is trapped near the bottom. This is due to something called capillary pressure. It is the difference in pressure across the oil-water interface. Water molecules and oil molecules are different, so naturally they're pulling the interface differently. Capillary pressure pulls the water into the small spaces such as those between the marbles in the jar or between the marbles. In the subsurface, the space between the rock grains are much smaller than what we have here. Capillary pressure is usually very high, meaning that multiple types of fluids can be found within the same pore space. Understanding and predicting how these fluids are flowing are extremely important in many subsurface engineering applications.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.